Well, hello, everybody. Happy Thursday. Make sure that you do the multi step inequality activator and that you take a picture of that or scan it and upload it to Google Classroom for me so I can take a look at it once you're done. Okay, yesterday we started looking at the quadratic function and we learned that the quadratic function is the function that we use to measure things that and explain things that are in motion. So we looked at an example of Tommy throwing a ball in the air, and that was modeled by a polynomial, or the quadratic function of negative 16x squared plus 64x plus 5. And it made a parabola, which is the graph of a quadratic function. And we use that parabola to tell different things about how the ball traveled in the air. And we're able to use that function to predict where the ball would be at different time intervals. Okay, so that was the use of the quadratic function. Now, one thing that I wanted to show you today is that the parabola is used in many areas of your life. If you look up at the top of the slide, you see a white communications dish up there, and it is definitely in the shape of a parabola. And you'll notice that in the middle of it, there is what we call a vertex to that parabola. And not only is there a vertex right there in the middle, okay, but also you have this piece right up here, the stand that it's on, which we're going to learn about today, would be its axis of symmetry. Also, you see here a television satellite dish that's in my yard, and you see a red arrow going towards the dish. That's how the dish receives transmissions. Then it beams those transmissions off the dish, which is in the shape of a parabola, into the little antenna piece here, which then takes the signal and it travels down through the black cord and into your house and gives you a picture on your television set. So communications and entertainment depend on the parabola and the quadratic function. Also, when you look at sports, here you've got a quarterback throwing a football. You've got a basketball player shooting a basket, just like you did in Will It Hit the Hoop yesterday. So parabolas are in the sports that we play. Even when it comes to national defense, the parabola is key to national defense. If you look over where we have Japan's ballistic missile defense system, every now and then you hear in the news about North Korea launching missiles over and at Japan. Well, those missiles launch in a parabola type orbit, and then you'll notice over there at Japan that they're firing back with intercepting missiles, that some are traveling at a straight line, and then the PAC-3 one is actually traveling in a parabolic shape. If you look over to the other side of the slide where you see the United States missile defense system, you see an intercontinental ballistic missile being launched from somewheres in the world, and it travels in the form of a parabola. And then we shoot missiles back to intercept that missile, and notice how the missile itself and our interceptors travel in the shape of a parabola. So whether it be communications and entertainment, or sports, or your personal safety and national defense, the parabola is there. So just let that sink in for a moment, that it's math that keeps you safe at night. The parabola keeps you safe at night. Math keeps you safe at night. So having said all that, let's go back to where we were yesterday as we were learning about the anatomy of a quadratic function. Okay, and so a quadratic function is a parabola, and on the graph, a parabola looks something like this. Okay, and we learned that a parabola has got a y-intercept, it's got x-intercepts, it also has what we call the vertex of the parabola right here, which is the turning point. Okay, we also learned that a parabola opens upward if it has a positive a value over here, or it's going to open downward if it has a negative a value. Okay, so today what we're going to look at is what we call the vertex or the turning point of the parabola, and what we call the axis of symmetry. And this is what an axis of symmetry is it's a line that goes directly through your parabola, right, like that, and it has its point of intersection is the vertex, and it is also the x value of the vertex. So we are going to use this formula right over here and our axis of symmetry to find the ordered pair for this vertex right over here. Okay? So that's what we're going to be doing today. So let's go to our next page. And for this page here, I would like all of you to recreate this on a sheet of paper, or you can print it out, scan it, and turn it in. So I'm going to pause for a moment and let you do that. Okay, so hopefully you were able to recreate this. And let's go ahead and start right now with learning how to find the axis of symmetry and then the vertex of a parabola. All right, so to find our axis of symmetry, or the line where x equals a certain value, we're going to use the following formula. We're going to use negative b divided by 2a. Okay, negative b divided by 2a. So what that means is, when I look at my function, we said that this is ax squared plus bx plus c. So my a is the coefficient of x squared, b is the coefficient of x, and then we have c. So if I have negative b divided by 2a, that means I'm going to have a negative 18 in this problem, because it's a minus 18, divided by 2, and then a is 3. Okay? So when I do that, two negatives make a positive, so that gives me 18 divided by 2 times 3, which is 6. So 18 divided by 6 means x equals 3. So I'm going to write up here x equals 3, because x equals this equation right here. Okay? So my vertex then, my first number of the ordered pair solution, the x value, is going to be the axis of symmetry, which is 3. So the next thing I do is I take the function that I have written here, which is y equals 3x squared minus 18x plus 1. Oh, let me make that a little bit better. Okay, so what I'm going to do then is take this value of x, which is 3, which I discovered over here, and I'm going to substitute that every place I see an x. So I'm going to have 3 times 3 squared minus 18 times 3 plus 1. So that means y equals, so 3 squared is 9. So here I have 3 times 9. And then 18 times 3 is going to be 54 plus 1. All right, so y equals a negative 26. So that means my ordered pair for my vertex, or my turning point for the parabola, is going to be 3, negative 26. So if I make a sketch of what this parabola is going to look like, I know it opens upward, because like we already reviewed, when I have a positive a value, it's going to open upward. So that's what it looks like. My axis of symmetry is the line right down the middle, which here is the line x equals 3. And then my ordered pair is the vertex, which is the turning point for this parabola. So I know that my parabola's turning point is going to be 3, negative 26. Okay, so that's how each of your answers ought to look. All right, so let's pause for a moment. All right, so for number 2, so I'm starting with finding my axis of symmetry, which was my value for x. So I use the same formula or equation that I did before, which is going to be x equals negative b over 2a. So if I look here, remember this is a, this is b, this is c. So negative b is going to be negative 6 over 2 times a, which is negative 3. All right, so then that gives me negative 6 over negative 6. So that means x equals 1. So my axis of symmetry is going to be x equals 1, which means it is a vertical line through 1 on my x-axis. So I come over here and I'm writing my ordered pairs for the vertex, and I put a 1 here. Then I take my function, y equals a negative 3x squared plus 6x minus 7. And I simply substitute the 1 every place I see the x. So that's going to be y equals a negative 3 times 1 squared plus 6 times 1 minus 7. So on my calculator, I'll do negative 3 plus 6 minus 7, and that's going to be y equals a negative 4. So up here, I'll simply put negative 4 for my y value. So that means the ordered pair solution for my vertex, which is the turning point of my graph, is going to be 1, negative 4. So when I go to make a drawing of this particular parabola, I need to notice that my a value is negative. So that means it's going to open downward. Okay? It's going to open downward. My axis of symmetry is going to be the line x equals 1. And then right up here, my ordered pair solution, or my ordered pair for my vertex, which is my turning point, is going to be 1, negative 4. All right, so I'll pause a moment, make sure you get this down. Okay, so for the next one here, so same thing, we're looking to solve for x. So let's do this one in purple. So x equals negative b divided by 2a. So again, this is a, this is b, this is c. So my b value is a negative 6. So that's going to be a negative 6 divided by 2, and my a value there is 1. So negative 6, 2 negatives make a positive, so that's going to be 6 divided by 2. So that means x equals 3. So for this particular problem, my axis of symmetry is going to be the line x equals 3, which is a vertical line through 3 on my coordinate plane. So then I'll put my 3 here, and then I'll take my function of y equals x squared minus 6x plus 13. And I will just substitute 3 every place there's an x. So that's going to be y equals 3 squared minus 6 times 3 plus 13. So 4 is your answer. 9 minus 18 is a negative 9 plus 13 gives me a positive 4. So again, to make my drawing, my A value is positive. So I know this is a parabola that's going to open upward. My axis of symmetry is going to go directly through the center of it, and it's going to be the line x equals 3. And then my ordered pair of my vertex, which is the turning point of my parabola, is going to be 3, 4. I'll pause. All right, so for the last one, I have y equals negative 2x squared plus 4x plus 1. So first thing, we want to find our axis of symmetry. So we're going to use what we've been using, which is x equals a negative b over 2a. So in this case, I have a, b, c. So that's going to be a negative 4 over 2 times a negative 2. So becomes negative 4, and negative 2 times 2 is negative 4 as well. So that means my answer is going to be x equals 1. So my axis of symmetry is the line at x equals 1, which is a vertical line through my point 1 on my x-axis on my coordinate plane. So I put the 1 there for the first part of my ordered pair. Then I have y equals negative 2x squared plus 4x plus 1. Okay, so 1 squared, so y equals a negative 2 plus 4 plus 1. So negative 2 plus 4 plus 1. My calculator says that's going to be y equals 3. So, same thing. When I make my drawing, since my a value is negative, that is a parabola that is going downward. Well, I can make a better one than that. All right, so my axis of symmetry is going to be the line that goes right through my vertex, which is my turning point of my parabola. So it is the line x equals 1. And then I have the ordered pair solution, or excuse me, the ordered pair of 1, 3. So that is where my vertex is. All right, so does anybody, if you have a question, please come up on Google Meet with me. Let me know and I'll send you a link, or you can email me your question. There is an assignment that is going to be up on Google Classroom now, which you probably saw already, called Finding the Vertex of a Quadratic Function. So go ahead and complete those exercises and do them on a separate sheet of paper. Scan or take a picture of it and turn it in. And I will talk to you tomorrow. Have a great day.